Hi students, in last class we discussed about uniform circular motion, centripetal acceleration and centripetal force. Now we will continue that class. In this class mainly we will discuss about Newton's universal law of gravitation. Now we will see the examples for centripetal force. First one is the gravitational force between moon and earth is a centripetal force. You know, there is a gravitational force between moon and earth. The gravitational force between moon and earth will act as a centripetal force for the moon, so the moon can revolve around the earth. The gravitational force between sun and planets is a centripetal force. You know, there is a gravitational force between sun and planets. This acts as a centripetal force, so the planets can revolve around the sun. Attraction force between electrons and nucleus in an atom. This is also centripetal force. There is a attraction force between electrons and nucleus. That attraction force act as a centripetal force, so the electrons can revolve around the nucleus. Here we can see electrons revolve around the nucleus. These are the examples for centripetal force. Now we will see one problem based on centripetal force. A car moves with constant speed of 10 meters per second in a circular path of radius 10 meters. The mass of the car is 1000 kilograms. How much the required centripetal force for the car? Here what are the given data? Mass of the car is given. Small m is equal 1000 kilograms. Radius of the circular path is given. That is 10 meters. Radius of the circular path small r is equal 10 meters. Velocity of the car is given. Velocity of the car v is equal 10 meter per second. Required centripetal force is given by, already you know the formula for centripetal force, that is Fc is equal mv square by r. Substituting the values, we will get centripetal force is equal 1000 into 10 square by 10. Here we can cancel 1 0 from 1000 and 1 0 from 10. So what we will get? Centripetal force is equal 10,000 newtons. 10,000 newtons can be written as 10 to the power of 4 newtons. Here we can see the centripetal force which is useful for the car to take the turn. Now we will see the Newton's universal law of gravitation. This is very important. Newton's universal law of gravitation. The universal law of gravitation was given by Sir Isaac Newton. It was given by Sir Isaac Newton. So it is also known as Newton's universal law of gravitation. According to universal law of gravitation, every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Newton's universal law of gravitation states that there is a attraction force between any two bodies in the universe. That attraction force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Here we can see two bodies. Their masses are m1 and m2. They are separated by the distance of capital R. The direction of the force is along the line joining the centers of two bodies. There is a attraction force between the two bodies, the direction of that attraction force is along the line joining the centers of the two bodies. Let two bodies A and B of masses m1 and m2 are placed at a distance of r from each other. Already we discussed two bodies having masses m1 and m2. They are separated by the distance of capital R from each other. Let F be the force of attraction between the bodies. Capital F is the force of attraction between the bodies. Then, according to Newton's universal law of gravitation, the force of attraction is directly proportional to the product of their masses. The force of attraction is directly proportional to the product of their masses. So, what we can write? Gravitational force is directly proportional to the m1 and m2. And also, the force of attraction is inversely proportional to the square of the distance between them. Force of attraction is inversely proportional to the square of the distance between them. So, what we can write? F is inversely proportional to square of the distance, that is r square. F is inversely proportional to r square. By combining these two equations, we will get F is directly proportional to m1 m2 by r square. F is directly proportional to m1 m2 by r square. To remove proportionality symbol, we will write one constant. So, we can write F gravitational is equal to the G m1 m2 by r square. Here capital G is the universal gravitational constant. When we remove proportionality symbol, we will write equal and we will write one constant. Here capital G is the universal gravitational constant. The value of the universal gravitational constant is same throughout the universe, and hence it is named as the universal gravitational constant. If you observe small g, gravity of the earth, it will vary from place to place. But if you observe capital G is the same throughout the universe. That's why it is called universal law of gravitation. The value of the G does not depend on the medium between two bodies. Universal law of gravitation does not depend on the medium between two bodies. If two bodies of mass 1 kilogram each are separated by 1 meter distance from each other, then G is equal to the F. If two bodies having masses 1 kilogram each and they are separated by 1 meter distance from each other, then universal gravitational constant capital G is equal to the force of attraction between them. That is, M1 is equal to 1 kilogram, M2 is equal to 1 kilogram and R is equal to 1 meter. Then F is equal to the G, or G is equal to the F. Here we can see by substituting M1 is equal to 1 kilogram, M2 is equal to 1 kilogram and R is equal to 1, we will get F is equal to the G. So, what is the definition for capital G? Universal gravitational constant G is numerically equal to the force of gravitation which exists between two bodies. It is numerically equal to the force of gravitation which exists between two bodies of unit masses. They having unit masses and kept at a unit distance. They are separated by unit distance. They having unit mass and they are separated by unit distance. Then the force of attraction between that bodies is equal to the G. What is the formula for universal gravitational constant? G is equal to Fr square by M1 and M2. G is equal to Fr square by M1 and M2. So what are the units? SI units of the universal gravitational constant is Newton meter square per kilogram square. By seeing the formula, we can write the units. What are the units of force? Newtons. What are the units of the distance? Here R is the distance, so meters. R square is there, so we can write meter square. And M1, M2 are the masses. What are the SI unit of the masses? Kilograms. So M1, M2, two masses are there. That's why we will write kilogram square. Newton meter square by kilogram square. This is very important. SI unit of the universal gravitational constant is Newton meter square for kilogram square. The value of the universal gravitational constant capital G is 6.67 into 10 power minus 11 Newton meter square per kilogram square. This is also very important value. The value of the universal gravitational constant capital G is 6.67 into 10 power minus 11 Newton meter square per kilogram square. Note, this law is valid for only spherical bodies. Newton's universal law is valid for only spherical bodies. We use the above formula for all bodies on the earth, though they are not spherical, because when compared to the earth, any object on the earth is very small and it is assumed to be point object. Actually, this law is valid for only spherical bodies, but we use the formula for all bodies on the earth. Why? Because even though they are not spherical, but when compared to the earth, any object on the earth is very small and it is assumed to be point object. That's why we will use this formula for any objects on the earth. Importance of universal law of gravitation. Now we will see the importance of universal law of gravitation. It is the gravitational force of each which binds everything of the earth. It is the gravitational force of the each which binds everything of the earth. The gravitational force of the earth is responsible to hold atmosphere around earth. Without gravitational force, already we discussed, earth cannot hold the atmosphere. Due to this gravitational force, earth is able to hold the atmosphere which is around the earth. The gravitational force of the earth is responsible for the rainfall and snowfall on the earth. Gravitational force of the earth is responsible for the rainfall and snowfall on the earth. The flow of water in rivers is also because of the gravitational force of the earth. The flow of water in rivers is due to the gravitational force of the earth. Here we can see the flow of water in a canal. This is due to gravitational force of earth. Newtons knew that the motion of the moon around the earth is approximately uniform circular motion. Already you know Newton's explained the uniform circular motion. He knew that motion of the moon around the earth is nearly uniform circular motion. Centripetal force is required to maintain the uniform circular motion. Already we discussed centripetal force is required to maintain the uniform circular motion. Without centripetal force, object cannot revolve around the other object. Moon cannot revolve around the earth. So he introduced the idea of force of attraction between the moon and earth. He introduced the idea of force of attraction between moon and earth. He proposed that earth attracts moon and termed it as gravitational force. You already know earth will attract all the bodies. Earth will attract moon. The force of attraction of the earth is called gravitational force. This gravitational force acts as a centripetal force and makes the moon revolve around the earth in uniform circular motion. The gravitational force of the earth act as a centripetal force, and this gravitational force makes the moon revolve around the earth in uniform circular motion. Here we can see earth, moon. The moon will revolve around the earth, and also we can see an apple. Acceleration of the moon is nothing but centripetal acceleration. Acceleration of the apple is nothing but acceleration due to gravity. The distance between moon and the center of the earth is represented by Rm, that is the radius of the moon. The distance of the moon from the earth is equal to the 3,84,400 kilometers. Remember these values, these are very important values. The distance of the moon from the earth is 3,84,400 kilometers, or we can say 3.844 into 10 power 10 centimeters. If you convert it into centimeters, we will get 3.844 into 10 power 10 centimeters. Time period of the moon. Time taken by the moon to complete one revolution around the earth is time period of the moon, that is equal to the 27.3 days. That is equal to the 27.3 days, or 2.35 into 10 power 6 seconds. If you convert it into seconds, we will get 2.35 into 10 power 6 seconds. Speed of moon is given by, you know the formula, speed is equal to the distance by time period. So speed of moon is given by distance is equal to the 2 pi r. Distance is nothing but circumference. So we will write speed of the moon is given by v is equal 2 pi r by t. Acceleration of the moon. Acceleration of the moon is nothing but centripetal acceleration, that is equal to the v square by r. Already you know the formula for centripetal acceleration, that is equal to the v square by r. So by substituting v values, we will get am is equal, in place of v we can write 2 pi r by t. 2 pi r by t whole square by r. So 2 pi r by t whole square can be written as 2 square is equal 4, 5 square r square by r t square. So in denominator r is there, in numerator r square is there. So we can cut r and square. What you will get? Am is equal 4 pi square r by t square. Acceleration of the moon is equal 4 pi square r by t square. Here r is the radius of the circular path of the moon, and t is the time period of the moon. You know pi value, pi is equal 22 by 7 or 3.14. By substituting these values, we will get am is equal 0.27 centimeters per second square. Acceleration of the moon is 0.27 centimeter per second square. Galileo found that acceleration of bodies acquired near the surface of the earth. Galileo found that acceleration of the bodies acquired near the surface of the earth is equal to 981 centimeter per second square. Galileo found the acceleration of the earth is equal to the 981 centimeter per second square, or 9.81 meter per second square. He compared both the acceleration of an apple to the acceleration of the moon. He compared both the acceleration of apple and acceleration of the moon. So AE by AM. AE is equal 981 and AM is equal 0.27. we will get 3640. We will get 3640. This is equation 1. Radius of the earth. The value of the radius of the earth is equal to the 6371 kilometers. Or if you convert it into meters, 6.4 into 10 power 6 meters. 6371 kilometers or 6.4 into 10 power 6 meters. By comparing radius of the moon's orbit and radius of the earth, we will get radius of the moon's orbit is 3,84,400 by 6,371. We will get nearly 60.3. This value is equal to the approximately 60.3. By taking squares on both sides, radius of the moon by radius of the earth whole square is equal to the 60.3 whole square. 60.3 whole square is equal to the 3640. Approximate value is equal to the 3640. Take this as equation 2. From equation 1 and equation 2, we will get acceleration of the earth by acceleration of the moon is equal to the radius of the moon by radius of the earth whole square. All of you observe this equation. Acceleration of the earth by acceleration of the moon is equal to the radius of the moon by radius of the earth whole square. Here acceleration of the earth, radius of the earth, they are in inverse variation. Acceleration of the earth is inversely proportional to radius of the earth whole square. Acceleration of the moon is inversely proportional to radius of the moon whole square. So what we can write? We get acceleration is inversely proportional to the square of the radius. Acceleration is inversely proportional to square of radius. If we remove proportional, we will write equal and one proportionality constant. A is equal K by R square. A is equal K by R square. Here K is the proportionality constant. From Newton's second law, force is equal mass into acceleration. F is equal ma. From Newton's second law, F is equal ma. So, if you want to get the equation for force, force on the apple by earth is equal to F into m is as it is and A is K by R square. So, what we will get? Force on the apple by earth is F is equal Km by R square. According to Newton's third law, the force on the apple by earth is equal to force on the earth by apple. Already you know, according to Newton's third law, for every action there is equal and opposite reaction. The force on the apple by earth is equal to the force on the earth by apple. Force on the earth by apple is F is equal Km by R square. These two forces are equal when following condition is satisfied. Force on the earth by apple is there and force on the apple by earth is there. These two forces are equal when following condition is satisfied. That condition is K is equal, capital K is equal G into capital M. M is the mass of the earth. Or K dash is equal capital G into small m. Small m is the mass of the apple. If we substitute capital K is equal G capital M or K dash is equal G small m. In the above equation, we will get force on apple by earth. Force on apple by earth is F is equal Gmm by R square. F is equal gmm by r square. Here F is the force on apple by earth. Here F is the force on apple by earth. G is the universal gravitational constant. Capital M is the mass of the earth. Small m is the mass of the apple. R is the radius of the earth. You can take capital M, small m, or you can take M1, M2. For the radius, you can take R. If it is the distance, you can take D. This is the proof for Newton's universal law of gravitation. All of you prepare well, make notes. We will continue in next class.